So in this video, we're going to look at some of the previous questions that were used for LANTITE, but we're going to focus on graphs, table, and data type questions. So the first one that fits into this category is question 1, to do with staff ratio. It says, this graph shows the average number of students per teacher in the Australian education system in 2013. So we've got the government, Catholic, independent sector, etc. But we're also shown here, we have a key that the coloured dots are primary and the white dots are secondary. Typical LANTITE style question, because we've got true or false questions to go through. So the first statement says the number of students per teacher in the independent secondary school is between 10. So let's just highlight some keywords. So independent secondary school. So we need to look for the dot that is representing the independent secondary. So I'll get my highlighter out. Secondary is the dots which are not colored, and independent is on this dotted line here. So based on that, we need to be looking at this point, and it says is between 10 and 11. And yeah, that works out, because if this is 10 and this is 12, halfway would be 11. So to say that this is between 10 and 11, so like 10 point something, that is true. The next statement says, for each sector, primary schools have more than twice the number of students per teacher compared to secondary schools. So this needs to be true for every sector. It can't just be one. So, for example, if we look at the primary in the Catholic system, when that needs to be twice as much when compared to the secondary Catholic system. So let's maybe try and put some rough numbers on each of these so we can compare. So this one we said was roughly 10 and a bit, so 10.5. And that's the independent primary. The independent secondary, that looks like it's quite close to 15. So we'll say 14 and a bit there, so maybe 14.8. So primary schools have more than twice the number of students per teacher compared to secondary school. Well, we can already see that this is not true in this situation, because if we double 10, that's going to give us 20, and that's not true here. Okay, that's less than 20. Or if you rounded it up to 11 and doubled that, you would have 22. So just looking at the independent system, it's not true, because it says for each sector, but we'll check the others. This roughly looks like it's 12 and a bit, so we'll say 12.5, whereas here this is quite close to 17. And again, that doesn't look like it's twice as much. 12.5 doubled is 25. So that's not true. And then here, this is, again, we'll just say a little bit less than 12.5, but we'll just round it to 12.5. And this is about 15.5. So doubling 12.5 would give us 25. So it's not true in any of these scenarios, okay? There is not more than twice the number of students, so we can definitely say that it's false. It actually isn't true for any of the sectors. At least it wasn't at that point. In general, Catholic schools have more students per teacher than government schools. The last statement says, in general, Catholic schools have more students per teacher than government schools. But if we look at the secondary, that's roughly 12 and a half, which is pretty much the same as the government. That was technically a little bit less, but it's on the higher end. And the primary is definitely the highest one. So it is consistent. If it's the highest in both secondary and primary, or it was at this point, then we can say that's true. In general, that is true, because it is higher in primary and it is higher in secondary. Questions 7 and 8 is about educational expectations. So we've got a composite bar chart here, and it says the graph shows information about the future education levels expected by parents for their children's age 8 to 9 in Australia in 2008. So this is in the past. But parents' expectations of children's future education level by gender and geographic remoteness. So again, focus on your key, because this dark blue represents secondary or less. This bit lighter blue is trade or vocational, and then so on and so forth. The lightest, where it's just pure white, is postgraduate. And it says, in which of these groups did almost exactly 2/3 of parents report degree as an expected level for their child's education? So where it says degree, okay, we're just going to focus on this part here because that's what we're looking for. And we're looking for 2/3. So you could calculate each one, or you could just look at the proportion of the bar chart, because this is done as a percentage out of 100. So if we're trying to find 2/3 of parents, and this is as a percentage, 2/3 is approximately 67%. That'll drive people crazy nowadays. So we're looking for a section which is roughly that much. Here we've got 51%, so that doesn't work. 45%, 36%, and here we go, 67%. So is this one here where it says major cities, but we want to look to see whether it's boys and girls as well. So we're just going to check the bit at the bottom. So this is the boys in the major cities was 51%, but the girls in the major cities is the 67% there. 2/3, just to be precise, is 66.666 reoccurring, but it does say almost exactly 2/3. So we don't have to be overly precise there. We can just say to the nearest percentage, it's 67%. And that's clearly that part here. So in question 8, we've got some true or false statements again. I'm just going to edit these in so it's all clear on one graph. The first statement says that the expected education level from parents is associated with where they live. So this is where you're like looking for a pattern. Association means, is there some type of pattern there? So when we look at the major cities, okay, it does seem that if we look here, the degree and postgraduate is significantly higher, and that's the same for this one as well. Then it seems to decrease a little bit when we go to the regional, and that pattern kind of remains similar here. So you're looking for a pattern. Are things increasing or decreasing based on where people live or whatever the criteria may be? And from what we can see, it does seem consistently that the people in major cities expect them to have a degree, or there is a higher amount of people or percentage of people who expect them to have a degree or postgraduate, and hence there is an association there. It doesn't mean that's what causes it, but there does seem to be some sort of pattern. And the other statement says, regardless of where people live, there is a similar expectation for boys as there is for girls. So again, we maybe can do some comparisons here. So let's have a look. Here, 51% of people expect them to have a degree and 11 postgraduate. So if we take that proportion and compare it to this, I don't think that's true just from that alone, because you can see that's considerably higher. There's a lot more people here who expects this from their daughters, the girls. And again, when we compare this section, you don't have to choose this, by the way. You should be able to get it from any. But if I was to compare this to this one here, again, there's a significant difference there. So actually, no, that statement is false. It does seem that the girls in this scenario, bless them, have higher expectations put upon them when it comes to achieving a degree, at least. So that statement based on this data is false. So question 11, we have got some data about resting heart rate, and it's shown in a table. It says this table shows normal ranges of resting heart rate for those of a different age. So newborns who are between 0 and 1 month old, their heart should beat between 70 and 190 for it to be considered normal. If they're between 2 and 11 months old, it should beat between 80 and 160 times per minute, so on and so forth. So let's start looking at the statements. The first statement says an 8-year-old child with a resting heart rate of 115 beats per minute is in the normal range. So it's an 8-year-old child. So let's find where an 8-year-old child should be. They should be in this group here. And if we look across, we are told that the beats per minute should be between 70 and 110. 115 beats per minute is actually just over this maximum amount. Okay, so the maximum for it to be considered normal is 110. 115 is above that. So based on this table, that statement is false. Next, we have a 12-year-old child whose resting heartbeat of 45 beats in 30 seconds is in the normal range. So they're trying to catch you out there because that's in 30 seconds. So if I just put here 45 beats in 30 seconds, remember this table isn't based on 30 seconds. It is based on per minute. So we need to know there's 60 seconds in a minute, and that is twice as much. So if we've doubled this, this is a rate. So we need to double this as well. So that would be 90 beats in 60 seconds. So in other words, 90 beats per minute. Okay. So now if we go to 12, we need to look at this group here. So they should be between 60 and 100 beats per minute. And we just found that 45 beats per 30 seconds is the same as 90 beats per 60 seconds. 90 is between 60 and 100. So that is a true statement. But they try to catch you out by not giving you the rate per minute straight away. And then the last statement says, in the first 6 years of life, resting heart rate consistently increases with age. Well, let's have a look. So it goes from 70 to 190, up to 80 to 160, from 80 to 130, and then 80 to 120. And actually, no, I wouldn't say this is consistent at all, because the maximum beats per minute is actually decreasing. So I know this has gone 70, 80, 80, 80, and then 75, and that kind of looks like it might be increasing. But check out the maximum. The maximum was 190, then it goes from 160 to 130. That's actually going down. So this isn't consistent at all. If anything, it might consistently decrease because the maximum is decreasing. But there's quite a wide range here in general. So to use the word consistently is not a safe assumption to do. Some people might be at the maximum, some people might be at the minimum. So it's definitely not consistent. Question 20 is about children and technology. So it says a survey was conducted for parents of children aged 0 to 5. They were asked to indicate which skill their child would have when it comes to using a tablet device unassisted. And the graph shows results from the survey. Again, just pay attention to your key. So the darker color represents children between ages 0 to 2. And the lighter color is between 3 and 5. And we've also got all of these different criteria. So swiping the screen, this shows us who would be able to do that. Trace shapes with their fingers. We've got 2 bars again to show us how many people or how many children would be confident doing that, so on and so forth. So it says, what percentage of children aged 0 to 2 were able to trace shapes with their fingers? So because they're 0 to 2, let's just make it clear that we need to do this one here, and they need to trace shapes with their fingers. So we're looking at this criteria as well. I'm just going to highlight the bar we should be referring to. So we want to make sure we're using the darker color of the key and that we're looking at this bar here. So we are looking at this bar. And when we do that, if we look at the end of the bar, that will tell us how many children. So if I go down, that is just above 40%. But if we want to be more specific, if we have a look here, there's 1 gap, 2 gap, 3 gap, 4 gap, 5 gaps. So 5 gaps is 20%. So if we do 20 divided by those 5 gaps, that gives us 4. So what that tells me is that every little gap is 4. So that would be 44%, 48%, 52%, and 56%. So this bit here is 44%. So quite a tricky question, in my opinion. Not only do you have to find the correct bar using your key and the information, you've also got to use the scale given by the diagram. So if you got it right, then good on you. Last but not least for this section, we've got a scalar plot. So a teacher administers online literacy. and numeracy assessment to her students. So you could think of this similar to NAPLAN as something which comes to my mind straight away. She's maybe preparing them for that. And she uses a software to produce a graph where numeracy score is our x-axis and literacy score is our y-axis. Boys are represented by a diamond, a dark blue diamond, and girls are a light blue circle. And it says one girl in the class has a numeracy score of 40. What is the girl's literacy score? So let's try and find the girl, most importantly. So she's got a numeracy score of 40. So if we go up from 40, that will help us tell what student it is. So it's this student here. Where I'm doing this online, it's a bit tricky to keep things super precise, but we're going to have to get the right answer. So we now need to go across to the literacy score. So if we just do a dotted line, and you can see what line I'm following, or trying to follow as close as possible, we would end up here, okay? One square above 40. So again, we need to use a scale to help us out. There are 5 squares between each of these. So between each of these, there's 5 squares, and that is a difference of 10. If we do 10 divided by 5, so 10 shared between the 5 squares, that gives us 2. So we're going up in 2s. Every square is 2. So here we are 40 and 1 square above. And if 1 square is 2, that means she must have got a literacy score of 42. We've got some true or false questions again. So students who have high literacy scores tend to have high numeracy scores. This is where you can do something called a correlation and look to see if there's a pattern. So if you draw a straight line and it goes like this, that suggests as one fin is increasing, so is the other. So this scenario works here. If we go from left to right, you can kind of see it's close to a straight line going up. So as one fin increases, the literacy scores, so do the numeracy scores. So that's true. The other scenario could be that it's going down, suggests as one fin increases, the other decreases. Or sometimes there's just not a pattern at all. And if you can't see a pattern, then this would definitely be false. But here we can see a pattern. They're both increasing, so this is true. Second statement says the mean literacy score of the boys was greater than the mean literacy score of the girls. So remember, we're looking at the literacy score, so we're going upwards. There's a lot more circles which are higher up in comparison to diamonds. Yeah, there's quite a few diamonds down here. So based on that, the girls did better in the literacy, so that statement is false. And it says the highest numeracy score by a girl was 63. So again, remember numeracy is this way. Okay, this is numeracy. So let's look for the student who is furthest across to the right and is a girl, who is this student here. So I'll just color her in green. And if we go down, that is her numeracy score. And it's trying to trick you again. She might be 3 squares from 60, but remember every square is 2. We established that earlier. That actually she scored 66. 60 plus 3 lots of 2 is 66 and not 63. So that is a false statement. If you need more help with data, graph, and table questions, then watch the video above where I cover more of this. I also have lots of content like this within my course, so if you are interested in that, then check the description down below where you can have a 5-day free trial.